Hello? Yeah, good afternoon. Yeah, I think I am clear now. I'm clear now?
Yes, sir.
Yeah, good. Okay, right. Now, just we'll try to recollect what we have done. Okay, so I think in the last class, morning, we have just started with what is called as basic basic system model. Okay, right. Now we are in the mechanical system, basically. Okay, the mechanical system, we are basically done with what is called as the springs. Okay, where F is proportional to X. So F is equal to K into X is the equation. Okay, then we are done with what is called as the dash point. Okay, where what is the equation? F is equal to C into V. Okay, right? F is equal to C into dx by dt. Okay, then we have done what is called as the mass. Okay, F is equal to m into a. Okay, where F into a is nothing but acceleration, that is dv by dt. So v is nothing but what is called as dx by dt. So that will be equal to m into d square x divided by dt square. So this is the one particular equation. Okay, right. F is equal to k into x and F is equal to c into dx by dt. So these are the three equations what we have discussed in the last class. Okay, right. Now continuing further. Okay, now this is about what is called as the force. Right. Then now we'll try to understand what is with respect to the energy. Okay. Next is this is with respect to the force. Next we'll try to understand with respect to what is called as the energy. Okay. Right. Now in the mechanical system or in the mechanical system building blocks. Okay. Now why energy is required is important. Now the previous case we have discussed with respect to the input force and the output as displacement. Okay. Is it clear? Clear now? Clear and loud? Clear?
Yes, sir.
Right. So the input is going to be the force and output is going to be the displacement. Now the second term we'll try to understand is with respect to the energy. Okay. Now why energy is required is now basically energy is required in order to stretch the spring or in order to compress the spring, and energy is required for you to accelerate the mass, and energy is required for the purpose of moving the piston in the against the resistive force. Okay. Right. When it comes to the spring, okay, when you stretch when you stretch the spring, okay, the energy is going to be present. Okay, now if you are going to release, energy is going to comes back. Now basically the energy stored in the spring is any idea what is the energy stored in the spring? What is the energy stored in the spring? Any idea? Energy right now, energy stored when there is an extension, x is equal to half into k into x square. Okay, half into k into x square. Okay, this is the energy which is going to be stored in the spring. That is half into k into x square. Okay, so we know that what, since F is equal to k into x. Okay, so we'll take it for x. X is equal to F by k. Okay, right. So we'll substitute the energy stored in the spring. Energy will be equal to what? Half into, right, k. Okay, x is x square. X is F by k. It is F square by k square. Okay, so that will be equal to half into F square by K. Okay, so this is the equation of into X square by K of into F square by K is the equation which is called as the amount of energy stored in the spring. Okay, right. So this is the first one. Then next is going to be, okay, now what is the energy stored? Okay, so what is the energy stored in the mass when it is moving at a velocity v? Energy stored in the mass, okay, moving at a velocity v is what? What type of energy? What type of energy is going to be there when a mass is going to move at a velocity v?
Kinetic energy.
Kinetic energy. That energy is called as the kinetic energy. Okay, right. Okay, so what is E of mass? What is E of mass? Can you say what is the equation for kinetic energy?
Half into m into v square.
Half into m into v square. Okay, so this is the equation of the energy stored in the mass when moving at a velocity v. Okay, right. So what is left out now? Left out is going to be what is called as the dash part. Okay, so dash part, okay, is the one, okay, where there is no energy stored. Okay, no storage of energy, but okay, but what it does, it dissipate the energy. Okay, that is what is required. The power is required. Okay, the power is required. The dash part dissipates the energy rather than storing it. Okay, the power P which is required, okay, for the dissipation of the energy is equal to P is equal to C into V square. Okay, P is equal to C into V square. Okay, now this is the equation. P is equal to C into V square. This is for the power for the dash part. Okay, now in all these cases, okay, now what we have discussed is we have got which are the basic building blocks. Can you tell me which are the basic building blocks under mechanical? Quickly, which are the basic building
Mechanical,
blocks?
electrical,
No,
hydraulic, pneumatic.
under mechanical building blocks under mechanical. Which are the basic building blocks under mechanical? Huh?
Spring,
Spring,
dashpot, mass.
mass. Okay, right. In all these cases, what was the input?
Force,
Force. What was the output?
displacement.
Displacement. Okay, right. Now you tell me, is this displacement was linear or rotational?
Linear.
Linear. Okay, now in all the above cases, the displacement what you have got is a linear displacement with the application of the force. Okay, right. In any other case, are we going to get a non-linear, the rotational moment? Rotational displacement, is it going to be there or not? Is rotational displacement is going to be there or not?
It will be there.
It will be there. Okay, right. Now, whatever we have discussed till now, okay, whatever discussed till now is going to be with the mechanical system building blocks for a linear displacement. Okay. Now, considering this, we have another thing called as rotational mechanical system. Rotational mechanical system. Okay, right. In rotational mechanical system, okay, right, as we have discussed already, the spring, dash part and mass, please remember this, spring, dash part and mass are the basic building blocks for a mechanical system whenever there is going to be a linear displacements, okay, without any of the rotation. Okay, if there is going to be a rotation, okay, if there is a rotation, okay, if there is a rotation, if there is a rotation, the equivalent three building blocks are or okay, number one, it is torsional spring. Okay. Number two, rotary damper. Number three, moment of inertia. Okay, right. So these are the three things which are going to be present. Okay, right. So moment of inertia, torsional spring. Number one, torsional spring. So this is equivalent to what? Torsional spring is equivalent to the spring. Okay. Rotary damper is equivalent to what? Rotary damper is equivalent to what is called as your the dashpot. Okay. Moment of inertia is equivalent to what? Equivalent to the mass. Okay. So these three okay are going to be used. Okay. In this case, what is the input? Okay, what is the output at least? What is the output? Is it linear displacement?
Non-linear.
The non-linear. It's not non-linear displacement. It is a
Okay.
rotary displacement. Okay. Means rotary displacement means you are going to express in terms of what? X or theta?
Theta.
Theta. Okay, right. We are going to express in terms of theta. Okay, now we'll try to understand how the equations are going to be vary for this particular case. Okay, right. Now, next we'll go further. Okay, right. Now, okay. Now you give a torque to this twisting torque. Okay, when you give a torque to it, okay, what is going to happen to this? Okay, right. So what is this inclination now? This one. What is this called as? Theta. Okay, right. Now, what is this one here basically? With the torsional spring. Now, the first one is what? Torsional spring. With the torsional spring, the angle theta. Okay, with the torsion for the torsional spring, T is the torque, correct? Which is the input. Okay, right. What is the corresponding output? Corresponding output will be equal to theta, which is the rotary displacement. Okay, rotary displacement. Okay, now what is T here? T is proportional. Tell me what? T proportional to theta. T will be equal to K into theta. Okay, is it clear? Okay, T is equal to K into theta. K is the stiffness of what? Stiffness of torsional spring. K is equal to stiffness of the torsional spring. Okay, right. Now this is with respect to the number one. Okay. Second one is going to be what? Now earlier I have used the piston. Okay, the piston. Piston gives you the rotary movement. Okay. Now we'll have what is called as something like this. Okay, right. Now, now what is happening now? What is happening with a rotary damper? This is what? This is a case of rotary. It's a case of rotary damper. Okay, right. When the rotary damper, okay, now in this case, with the, can you able to understand?
Yes, sir.
Okay, now with the rotary damper, a disc is what is happening with the disc here? The disc is rotated in a fluid. Okay, the disc is rotating in a fluid, and the resistive torque is proportional to, okay, earlier what is proportional to in the dashpot, T was proportional to what? Sorry, F was proportional to
Velocity.
velocity. Okay, now here F is replaced by what? Replaced by rotary torque. Okay, so F is replaced by, tell me,
Rotary torque.
T. Okay, proportional to, okay, what is V? V is velocity. If it is angular velocity, what is the term we use?
Omega.
Omega. Okay, so omega. Okay, so T is equal to C into omega. Okay, so what is omega? Omega is nothing but the angular velocity. Angular velocity is nothing but it is the rate of change of angular displacement with respect to the time. Correct, right? So V omega is nothing but rate of change of angular displacement with respect to time. Therefore, what I can write, T is equal to C into, so this if I express in terms of input and output, because my output is what? My output is theta. Are you understanding? Getting it or what?
Yes, sir.
The input value is T, output value is theta. That is why I am expressing omega in terms of theta. So what is omega in terms of theta?
D theta by dt.
D theta by dt. Okay, now this is with respect to what is called as the second one. Okay, right. Then third one is going to be what? Third one is going to be the moment of inertia. Okay, what is moment of inertia? Okay, is expressed as I. Okay, so earlier F is equal to mass into acceleration. Okay, right? So here, okay, here the moment of inertia has the property that greater the value of torque. Okay, greater the value of torque means more amount of torque is required to get the angular acceleration. Okay, so T will be equal to what? So T will be equal to here, T will be equal to I into A. Okay, I into A. So what is I? I will be as it is. A will be what? D omega by dt. Correct? So I'll keep it as it is. So I'll express omega in terms of theta. So it is d theta by dt. Therefore, T will be equal to I into d square theta by dt square. Okay. So this is with respect to d square theta by dt square. So this is with respect to what is called as the moment of inertia. Okay, right. Now similarly, now what shall we do now is we'll proceed with understanding the energy. Now this is with respect to the force. Okay, or the torque. Okay. Next one is with respect to the energy. Okay, so energy is stored in what? Energy is stored in torsional spring. Is equal to, what is the equation? What is the equation? What is energy stored in the spring?
Half kx square.
Why you are the only one present? Huh? Why others? What is the energy stored in the spring? What is the energy stored in the spring? E is equal to
Half
Half k
kx.
square, sir.
half into k into x square. So now similarly, what is the energy stored in the torsional spring? Half into
K theta.
k into
Omega.
Replace x by theta, correct? Right? Theta square. Okay, right. So what is t? We know that theta will be, sorry, t will be equal to k into theta. Okay, so theta will be equal to t by k. Okay, so therefore E of torsional spring is equal to, what is that? Half into k theta is nothing but t square by k square. Okay, so 1k gets cancelled. Therefore, E of torsional spring will be equal to half into k, sorry, not k, it is t square by, okay, half into t square by k, half into t square by k, right? Then this is with respect to the energy in the torsional spring. Then what is the energy stored in the mass? With kinetic energy, E of mass, E of moment of inertia. E of moment of inertia is half into m.
mv theta.
No, here
Omega square.
m into omega square. Okay, right. Then E with respect to, sorry, power stored. Okay, power dissipated with the damper is equal to what? P is equal to m into, sorry, C into V square. C into V square is for the rotary damper. Sorry, for the dashpot. Okay, for the rotary damper, P is equal to
C into omega square.
C into omega square. Okay, right. Okay, right. This is about the building block. Okay, write down this question. Briefly explain the various building blocks. Briefly explain the various building blocks under mechanical. Briefly explain the various building blocks under mechanical system. Express them mathematically. Express mathematically the equation for force and energy stored. Express mathematically the equation for force and energy / power stored. Power stored. Okay, right. Now just a summary. Okay, this is just the summary of the whole of the thing what we had done. Okay, so I will just write like this. Okay, now what is the building block? Building block is mechanical. Okay, right. How many building blocks are there? How many? First one is broad classification is, first one is translational. Correct or what? Translational. Okay, right. Name of, write down. I want you to fill this. Name of building block. Then equation for force. Then equation for energy or power. Okay, write down one by one. Spring, dashpot, mass. Write down the equations. Sandesh?
Yes, sir.
Yeah, what is F?
K into X, first thing.
Okay, F is equal to K into X. Okay, on the other side, you just all of you fill that F is equal to K into X. Then F is equal to next one for dash part
F is equal to C into dx by dt.
C into dx by dt. Okay, next F is equal to
F is equal to m into d square x by dt square.
dt square. Okay, correspondingly you write for the energy. Correspondingly you write for the energy. E is equal to half into
F square by K.
F square by K. Next,
For mass, half into m into v square.
okay, for mass half into m into v square. For dash part, it is not the energy, it is dissipation of the power.
C into v square.
C into v square.
V square.
Yeah. Okay, that is for one case. Next, Sukrut,
Yes, sir.
can you just show what is that you wrote?
Sir, I'm not getting you, sir.
Huh?
Which one to show, sir?
No. Just show me the work that you have done today. Now, this table. Can you show me the table that you wrote?
Sir, I'm writing, sir. Writing.
Huh?
I'm writing, sir.
Yeah. Dhanush?
Yes, sir.
Yeah, next one you write. Rotational spring. What is the equation?
Sir, T is equal to K into theta, sir.
Okay. Energy?
Sir, for energy, half K into T square by
Half K na. Half into
T square by K.
are you all writing?
Yes, sir.
Yes, sir.
Sure. Can
Yes, sir.
I assume that you are all writing?
Yes, sir. Writing.
Dhanush,
Yes, sir.
can you show me?
Yes, sir. I'm writing, sir.
Show me.
Yes, sir.
Switch on the video. Okay. Tell me. Next, rotational damper. Rotational damper. Next one.
Sir, T is equal to C into d theta by dt, sir.
Okay. Power.
That is for rotational damper, sir.
Okay. For the power. Power.
T is equal to I into d square theta by dt square.
Power. Dhanush. I am asking about the power. Power for rotational damper.
Sir, P is equal to C into omega square, sir.
Okay, right. Mithun, are you there?
Yes, sir.
Yeah. Tell me for moment of inertia, last one.
T is equals to I into d square theta by dt square.
Okay. Energy?
Half into I into omega square.
Okay, right. Okay, all of you, answer to this question. Okay, so completely. So I want you to answer to this question with from the beginning. Okay, that is, as I told, with the equation for the translational system and for the rotational system. You write down all the equations, okay, and upload the same onto your Google Classroom. Is it okay?
Yes, sir.
Okay, today, anytime today, before tomorrow's class, I want you to write the answer to this question and upload onto the Google Classroom. Anytime is okay for me, but before come for tomorrow's class, it should have been done. Okay, right?
Yes, sir.
Okay, right, good. Okay, right. Shall I assume Sandesh, Sukrut, and Dhanush have done it?
Yes, sir.
Because I
I've
have
done,
told
sir.
you to show, you are hesitating. Okay, I'll assume. Okay, I'll trust and I'll assume that you are done. Shall I go like that?
I've done.
Yeah. Okay, fine. Good. Okay, next. Next, we will take the heading as, okay. Now at this stage, what have you known about the mechanical building blocks? What have you known about the mechanical building blocks? What have you understood up till here? What have you understood?
Like what energy is stored.
No. What are those? What are those actually? Okay. Now you got this, no? Spring dashpot mass, okay, and torsional spring, rotary damper, and moment of inertia. What are those 6 called as?
A system.
No. System is mechanical system. Okay. What are these? Under mechanical system, what you call them as? The spring, dashpot, and mass are called as what?
Mathematical modeling.
Cheh. What
Building
are
blocks.
Components of
no? What is that? What is the specific name? Basic
system models.
you have given the heading, no? Basic building blocks. Okay, basic building blocks for which system?
Mechanical.
For mechanical system. Are you understanding? Now the question will be, briefly explain the basic building blocks for mechanical system. Okay. So under this, as I told, translational. Under this, translational. Then next is going to be down. Okay. VP check.
Rotation.
Rotational. Okay. Translational, rotational. Okay. Right. Under translational, again I am making springs, dashpot, and mass. Correct? Yes. Under rotational, quickly tell me. Under
So
rotational,
same spring dash. No,
same. Is it same?
torsional spring,
Torsional spring, then
rotary
rotary
dam,
damper, and
and moment of inertia.
moment of inertia. Okay. Right. Now, what is that you have done now is you have understood what are the six building blocks under mechanical system, 3 under translational system, and 3 under the rotational system. Okay. Right. Now, take the next heading as building up a mechanical system. Okay, building up a mechanical system. Okay, right. Let the heading as building up a mechanical system. Okay, right. Now, just take this diagram. I'll explain. Okay, noted down. Noted down.
Yes, sir.
Okay, right. Now, what is this diagram is? Okay, what system it is? It's a spring, dashpot, and mass system. Generally, we call it a spring mass dashpot system. Are you understanding? We have now the diagram shows the spring mass damper system. Okay, for which now if I consider this, okay, so this is what is a the spring dashpot mass system. Okay, right. What is the input for this system? What is the input for this system?
Force.
Tell me. Huh? Huh?
Sir.
Force. Force is the input for this system, and output is going to be
Displacement.
displacement. Okay. Whether the diagram that we wrote belongs to translational mechanical system or rotary mechanical system.
Translation.
Okay, translational mechanical system. Okay, right. Now the figure indicates what? The figure indicates the three basic building blocks, okay, put together as a single diagram called as the spring mass dashpot system. Okay, so we have a mass and we have a spring and the dashpot. Okay, now I need to evaluate. Okay, I need to evaluate what? I need to evaluate the relationship between the input force and the output displacement. Okay, we need to evaluate the relationship between the input force and the output displacement for which system? For the spring mass damper system. Okay, right. Now for that, what is that we are considered? We need to draw what is called as a free body diagram. Now in order to write the equation, we need to write what is called as a free body diagram. Okay, so what do you mean by free body diagram? Any idea? What do you mean by free body diagram? What is free body diagram?
Sir, it represents the system wherein no forces are acting. Sir.
Okay, right. The free body diagram is nothing but whichever the forces which are going to be acting on that particular body, okay, we are going to represent, okay, and that representation is called as free body diagram. Okay, right. Now on this, the free body diagram is on the mass. Okay, so you just write, I'm writing the free body diagram for the mass. Okay, right. Now what is the force? Now this is the force that you are applying. Are you understanding? So this is the force that you are applying. Now when you apply the force in the diagram, what we have what is called as the spring. Yes or no? Okay, yes or no?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay. Now what is the force due to the spring? Will it act here or will it act opposite to this? When I pull a spring, okay, there is a resistive force, correct? When I pull a spring, there is a resistive force which acts what? Which acts in the reverse direction. Yes or no? What is this? What is this force?
Resistance
force
force.
is due to, this force is due to
Resistance.
what? Due to?
Resistance.
No, due to what? Due to which component?
Stiffness, sir.
Due to
Spring.
the spring. Component is spring, but the value what you are told is stiffness is correct. This is the force due to the spring. Is it the only force?
No, sir.
There is one more force. What is that?
Dashpot.
Okay, this another is force due to dashpot. Yes or no? Clear? Now this represents what is called as the free body diagram. Okay, free body diagram for the system. Okay, now in the free body diagram of the system, this diagram, okay, this diagram of the mass and the forces acting on it, okay, the diagram of the mass and the force acting on it is called as the free body diagrams. Okay, right. Now we'll try to understand. Okay, so in order to make the mass to be in the same position, okay, what is going to happen now? The net force, okay, the net force applied to the mass is going to be equal to what? What is the net force applied to the mass? We'll take the mass. Okay, considering I'll go to the next page now. Okay, right. Okay, we'll be here only. Okay, right. Now for the mass. Understand? For the mass I am writing. Consider only the forces that act on that block. Okay. So what is the net force applied to the mass? Write down. Net force applied to the mass will be equal to force minus what? Minus
Force due to spring and force due to damping.
force due to spring minus force
Due to damping.
due to damping. Okay, right. Now, if we go further, okay, right. Now, that is net force applied to mass M will be equal to F minus. Okay. What is the force due to spring? What is the force due to spring? Equation. Okay, that's why I have asked you for it.
K into X.
K into X minus. What is the force due to the dash point?
K into dx by dt.
No, K na.
CV.
C into V.
C
It is not
into-
K, it is CV. Okay, C into V. Okay, right.
Okay.
Where what is V? V is the velocity. Correct. Velocity of the piston. Okay, right. Clear or what?
Yes, sir.
Okay, right. Now, what is the left hand side? What is LHS? What is left hand side actually? Net force applied to mass. Force applied to mass. What is the force applied to mass? What is the force applied to mass?
F, sir.
What is that equal to?
M into G, sir.
M into
G, sir.
G.
Yeah.
M into A. Correct? Correct or what?
Yes, sir.
M
Yes,
into
sir.
A. Okay. So, okay. A, can you express this A in terms of displacement?
D square X by dt square.
D square X by dt square. Okay. So this has become what? This is your left hand side. Okay. Now let me write. Okay. What is the left hand side now? M into D square X by dt square equal to F minus K into X minus C into, can we write V in terms of displacement?
Dx by dt.
Dx by dt. Okay, right. So now we'll rearrange. Okay. What shall we write? We'll write it as a differential equation. So first we'll write the higher order differential term. What is the higher order term? M into d square x by dt square plus c into dx by dt, correct, plus k into x, that will be equal to f. Okay. So this is the equation which represents, okay, so this is the differential equation representing what? Representing what? Spring, mass, damper system. Okay, are you understanding? Okay, so relationship is what? Relationship is with force and displacement. Yes or no? Displacement. Okay. Is it a single degree of first order differential equation or second order differential equation?
Second order.
Okay, it is a second order differential equation. Okay, in the exam it might come like, okay, so briefly derive a second order differential equation to represent a spring mass damper system. Okay, so now you have to write the diagram. Okay, write the diagram, okay, of spring mass and damper write the free body diagram, and write this particular equation. Okay, so this is what is that you need to write. Okay, so if it is going to be a case like this. Okay, right. Now one more. Okay, right. Now with this, we'll just move on to another small exercise. Okay, right. Take this diagram. Okay, write down, derive a mathematical model. Write down, derive a mathematical model to represent the following system. Derive a mathematical model to represent the following system. Write down the system. Okay, spring 1 and spring 2. So this is the equation. Okay, right. Can I write the free body diagram for this? Have you noted this diagram first?
Yes, sir.
Okay, shall we write the free body diagram?
Yes.
Okay, what I should consider? The forces acting on the mass I should consider. Yes or no? Yes or no?
Yes, sir.
Okay, on the right side, what force you are going to get? Just right?
F.
Force.
Yeah.
F.
Okay. On the left side, what is the force you are going to get?
Force due to spring 1.
Okay, force due to spring 1. What is equal to
K1 X1.
K.
K1 X. Okay. Next, force due to spring 2. Okay, let's assume that the stiffness is what is that the displacement. Okay, right down K1 into displacement as same. Let's assume the displacement as same is equal to K2 into X. Correct or what? Okay, right. Now you write down what is the net force. Equation. Write the equation. What is the net force? Net force applied on the mass M equal to what? Tell me.
F minus
F minus
K1X
K1X minus
K2X.
X. Okay, right. What is the LHS? What is LHS? LHS is net force applied on the mass. That will be equal to what?
M into A.
M into A.
A.
That will be equal to M into
T square X by dt
X
square.
by dt square. Okay, so write down. Therefore, M into d square X by dt square equal to F minus K1 into X minus K2 into X. Okay, so rearrange M into d square X by dt square plus K1 plus K2 into X. That will be equal to F. Is it clear?
Yes, sir.
Okay.
Yes, sir.
Right. So this is another representation. Now here, how many building blocks we have considered? How many building blocks are there?
Two building.
We have only two building blocks. One is the mass, other is the
Spring.
spring. Okay. So previous one, what we have considered is the whole spring mass damper system. Okay. Now here it is only mass spring system. Are you understanding? Spring mass system, let's say. Okay. Right. Previous was spring mass damper system. This one was only the spring mass system. Okay. So now you have got two different expressions. Is it clear now? Are you understanding?
Yes, sir.
Okay, right. Okay, right. Now we'll continue, and we have another small diagrams which are going to be there, and we'll discuss that in tomorrow's class. Okay, right. So we shall close the class now. Okay, right. Okay, right. So thank you. May I appear there? Yeah, Dhanush, Mithun, no number. Srinidhi is not there, I think. Yeah. Okay. So except Srinidhi, all are present. Okay. Right. Fine. Okay. Thank you. We'll meet in the tomorrow's class. Huh?
Thank you, sir.
Thank you, sir.
Okay. Thank you. Bye.
Thank you.